Strong induction is similar to induction, except that you might use more than one of the previously proved statements in the inductive step. So, for example, in the base case, you're going to prove statements P1, P2 up to Pn for some number n, and then in the inductive step, to prove Pi plus 1, you're going to use P1 and P2 and P3 up to Pi to then prove Pi plus 1. Whereas in induction, you only used the last statement that you proved, Pi, to prove Pi plus 1. And in this case, P1, P2 up to Pi are all called the inductive hypotheses. So let's look at an example. We're going to define a sequence A1, A2, A3, and so on, defined by A1 is 1, A2 is 1, A3 is 1, and then AI is the sum of the previous 3 terms. So it's AI minus 1 plus AI minus 2 plus AI minus 3, so whatever the last 3 terms were. And in other words, A4 will be 1 plus 1 plus 1, which will be 3, and then A5, we would add A4, which is 3, plus A3, which is 1, plus A2, which is 1. So that's going to equal 5. And then A6 would be 5 plus 3 plus 1. So you always add the last 3 terms, the 5, the 3, and the 1. And so that's going to give you 9. Now the claim is that in this sequence, AI is odd for every number I. So to prove this, we can use strong induction. And the base cases would be A1, A2, and 3, which were given, and they're all odd. And we could also use A4, A5, and A6 since I computed them, but you wouldn't need to compute them for the proof. I just did that for an example to show you some more terms in the sequence. So let's assume n is bigger than or equal to 3, and A1 through AN are all odd. And the goal is to show that AN plus 1 is also odd. Well, we know that AN minus 1, and AN minus 2 are all odd. And here's where we're using strong induction, so we're using more than one of the previous statements. And in fact, we're assuming A1 through AN are all odd, so we can use the fact that the last 3 terms are all odd. And since they're odd, that means there exist integers u, v, and w, such that AN is 2u plus 1, AN minus 1 would be 2v plus 1, and AN minus 2 is 2w plus 1 for some integers u, v, and w. So AN plus 1, which by definition is AN plus AN minus 1 plus AN minus 2, is 2u plus 1 plus 2v plus 1 plus 2w plus 1 for some integers u, v, and w. And that can be rearranged to 2 times the quantity u plus v plus w plus 1, all plus 1, which is 2 times something. This here in this box is just a number, which we could call x. I'll put an x over it all. 2 times some x plus 1, which makes it odd. And therefore, AN plus 1 is odd.